Now, in this lecture, we will find the size of 2 times AP. Okay? Or the value of 2 times AP. Actually, you can see the drawing triangle ABC, and side AC equals to 70 units. Side AC of the triangle ABC equals to 70 units, and the side BC of triangle ABC equals to 50 units, and side AB of the triangle ABC equals to 90 units. We have also circle that its center is P, and P is point that is on side AB of the triangle. P is the center of the circle. Okay, and actually side AC of the triangle is tangent to the circle in point that we will call that point D. Okay, again, side AC of the triangle is tangent to the circle at point D. Okay, and also side BC of the triangle is tangent to the circle at point E. Again, side BC of triangle ABC is tangent to the circle at point E. Okay, so now we will connect points P and C together by a line. Okay, and we also will connect points P and E by a line. So actually PE is the radius of the circle. Okay, PE is the radius of the circle because it starts from the center of the circle until it touches the circle itself. So it is defined as a radius of the circle. Okay, and we will connect also points P and D together by a line. As you can see, PD is also the radius of the circle. Okay, PD is the radius of the circle, and PE is also the radius of the circle. Okay. Now we have a rule that if you have a circle and from external point of the circle, external point, that is to say not inside the circle and not on the circle itself but outside the circle. It is defined as external point of the circle. Let's call this point V. From point V, if we draw two tangents to this circle, okay, this is the first tangent and this will be the second tangent. So these tangents are equal to each other, okay? Or if we mark the touching point of this tangent in the circle as F, and we will mark the touching point of this tangent in the circle as M, then we can say that FV equals to MV. Okay? FV equals to MV, or whenever you draw from external point of a circle two tangents to the same circle, then those two tangents are equal to each other. That is to say, VF is equal to VM. Okay? Or FV equals to MV. Okay, so according to this rule, we can say that in our drawing, CD, that is tangent to the circle, equals to CE, that is also the tangent to the same circle. Because, so, from external point of that circle, that is to say, from point C, we drew two tangents to this circle, tangents DC and tangents EC. According to the rule that we learned now, they must be equal to each other. So CD equals to CE. Okay, CD, that is tangent to this circle, equals to CE. That is also the second tangent to the same circle that is drawn from external point of the circle, because C is the external point to this circle, because it is not inside the circle and it is not on the circle itself. So it is defined as external point to the circle, and we draw two tangents two tangents to this circle from external point to this circle. Therefore, those two tangents equals to each other, that is to say CD equals to EC, or CD equals to CE, okay? And as I have already told you, PD is the radius of the circle. We can mark it as radius, and P is also the radius of the same circle, so it is also can be defined as R. Therefore, PD equals to PE equals to R, because both those lines are the radius of the circle. So PD equals to PE equals to the radius of the circle, okay? PD equals to PE equals to the radius of the circle, okay? And of course, PC equals to itself, okay? PC equals to PC. So we have actually triangle, in triangle PDC, this triangle, in this triangle, PDC, we have three sides that equals to three sides of triangle PCE. Because CD in this triangle equals to CE in this triangle, PD in this triangle equals to PE in this triangle, and PC in this triangle equals to PC in this triangle. So we actually can deduce that triangle PDC is congruent to triangle PCE, or triangles PDC and triangle PCE are overlap to each other, or they are congruent triangles. Okay, so this triangle is congruent to this triangle. Why? Because triangle PDC has three sides that equals to three sides of triangle PCE. CD of this triangle equals to CE of this triangle. PD of this triangle equals to PE of this triangle, and PC of this triangle equals to PC of this triangle. So whenever you have in two triangles three sides of one triangle equals to three sides of the other triangle, you can say that those two triangles congruent to each other, or those two triangles overlap to each other. or those two triangles overlap. Okay, so triangle PDC overlap triangle PCE. Okay, and for that reason we can also deduce that angle PCE I marked it in the red color. Angle PCD, angle PCD is equal to angle PCE. I marked it in the blue color. Angle PCD equals to angle PCE. According to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so we can write that angle PCD, this angle in the right side, in the red color, equals to angle PCE. I marked it in the blue color. Okay, according to the rule that corresponding angles in congruent triangles are equal to each other. I will repeat again. Angle PCD in the red color equals to angle PCE in the blue color, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? Angle PCD equals to angle PCE according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so if we mark this angle as theta, if angle PCD is theta, so angle PCE will be also theta, because they are equal to each other. Okay? Okay, so in the next step, I will draw triangle ABC again. Okay. So this is actually triangle ABC. I drew it again, and actually in triangle ABC we have as you saw in this picture, this angle is theta and this angle is also theta. So I do it again. This angle theta and this angle is also theta. So actually we can define line CP as angle bisector. Why? Because CP divides angle BCE to two equal parts. It divides angle BCE to theta and theta. Okay, so PC is angle bisector and it hits side AB at point P. Okay, so according to angle bisector theorem, the angle bisector divides the side that it hits in a triangle, that is to say, as you can see, angle bisector is CP and it hits angle AB in point P, so it divides side AB in a ratio that equals to the ratio of the angle of the sides of the angle that it divides to two equal parts. So the ratio that angle bisector AP divides AB, that is to say, the ratio is AP over BP, yes? So that ratio equals to the ratio of the angle sides. The sides of the angle that it divides to two equal parts. We have angle ACB is divided to two equal parts, and angle ACB consists side AC and side CB. So the ratio of the angles sides, that is to say AC over BC, is equals to the ratio of the AP over BP, because the angle bisector CP divides side AB in the same ratio as the ratio of the sides, the angles sides. So the angle sides that it divides to two equal parts is AC and BC. So the ratio between AC and BC equals to the ratio between the sides, between the what is created after CP angles dissector CP divided angle AB to two parts. So angle CP, angle bisector CP divided side AB to two parts, and the ratio between those two parts, that is to say the ratio between AP to BP, equals to the ratio between the triangles angles sides, the angle that is divided to two equal parts. The ratio of its sides, that is to say is AC and BC, or AC over BC, equals to the ratio that the angle bisector CP divided side AB, because the angle bisector CP divided angle AB to two parts, and the ratio between those two parts, that is to say the ratio between AP and BP, is equals to the ratio between the angles sides, and the angle sides are AC and BC. So the ratio between AC and BC is equals to the ratio between the two parts that the angle bisector divided side AB. Okay, so AP over BP, that is the two parts that was created after angle bisector CP divided side AB. That ratio equals to the ratio of the angle sides, and the size of the angle that is divided to two equal parts is AC and BC. So the ratio between AC and BC, AC over BC, equals to the ratio between the two parts that side AB was divided by angle bisector CP. The angle bisector CP divided side AB to two parts, and the ratio between those two parts, that is to say the ratio between AP and BP, equals to the ratio between the angle sides. The angle that was divided to two equal parts has two sides, side AC and BC. So the ratio between those two sides, that is to say AC over BC, equals to the ratio between the two parts that was created by angle bisector CP, because CP divided angle AB to two parts, and the ratio between those two parts are AP over BP. Okay, so AP over BP equals to AC over BC. Okay, so actually this is the angle bisector theorem. Angle bisector theorem. Okay, so we can summarize that according to angle bisector theorem, AP over BP equals to AC over BC, because the angle bisector CP divides side AB in ratio that equals to the ratio of the side of the angles that is divided to two equal parts. The ratio between the sides of the angle that divided to two equal parts is AC over BC, and it is equals to the ratio of the between the two parts that was created after angle bisector CP divided side AB to two parts. So the ratio between those two parts, AP over BP, equals to the ratio between the angle sides that was divided to two parts. And the ratio between those angle sides is AC over BC. Okay, so AP over BP equals to AC over BC. Okay, so now we can define AP as X and as you see here, AB is given to us, AB equals to 90, so PB will be equal to 90 minus X, or AB minus AP will be equal to PB, that is to say 90 minus X will be equal to BP, that is 90 minus X. So BP equals to 90 minus X. So in equation 1, AP over BP equals to AC over BC, we can substitute AP by X, because AP equals to X, and BP to 90 minus X, because BP equals to 90 minus X. Okay, so we can write that X over 90 minus X equals to AC over BC. Okay, in equation 1, we substituted AP by X and BP by 90 minus X, because AP equals to X and BP equals to 90 minus X. but we also know that AC equals to 70 and BC equals to 50, so we can substitute AC by 70 and BC by 50. Okay, so we will do it now. So AC equals to 70, so we will substitute AC by 70, and BC equals to 50, so we can substitute BC by 50. Okay, I will show you again. X over 90 minus X equals to AC, but AC equals to 70, so we can substitute AC by 70, and BC equals to 50, so we can substitute BC by 50. Okay, so here 70 equals to 7 times 10 and 50 equals to 5 times 10, so we can write it, we can rewrite the equation 1. So, as you can see here, instead of 70, I wrote 7 times 10, and instead of 50, I wrote 5 times 10. Now, as you can see, in this equation, we have 10 in the numerator, and we also have 10 in the denominator. Okay, we have 10 in the numerator, and we have also 10 in the denominator. So we can eliminate 10 from the numerator and the denominator. Okay, so we got that X over 90 minus X equals to 7 over 5. Okay, because we eliminated 10 from the numerator and from the denominator. Okay, so we left with 7 over 5. Now we can multiply both sides of the equation by 5. Okay, we will get that 5 times X over 90 minus X equals to 7. So we multiplied both sides of the equation by 5, so 7 divided by 5 times 5 equals to 7, and X over 90 minus X times 5 equals to 5X over 90 minus X. Now we can multiply both sides of the equation by 90 minus X. Actually, as you can see in the picture, X is less than 90 units, AB equals to 90 units and X is less than 90 units. So 90 minus X will always be positive number, and actually the main point is that 90 minus X will never be 0 because X is less than 90. So 90 minus X can never be 0, so we can multiply both sides of the equation by 90 minus X. Okay? So we will get here 5x equals to 7 times 90 minus x. So we multiplied both sides of the equation by 90 minus x. So 5 divided by 90 minus 6 times 90 minus 6 equals to 5x, or 5x divided by 90 minus 6 times 90 minus 6 equals to 5x, and 7 times 90 minus 6 equals to 7 times 90 minus 6. So here we will open the brackets. So we will get that 5x equals to 630 minus 7x. Okay, here, as you can see, we opened the brackets here. 7 times 90 is 630, and the 7 times minus 6 equals to minus 7x. So here we can add 7x to both sides of the equation. So we will do it now. Five x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 680 and 30. Okay, I repeat again. 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we will divide both sides of the equation by 6. So 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. I will repeat again. 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. Now, as you can see in the drawing, we defined here that x equals to AP. Okay, we defined that x equals to AP, so we can write here that x equals to AP. So 2 times 6 equals to 2 times AP. So we can write the first equation, okay, as you can see here, x equals to AP, so 2x equals to 2AP, 2 times AP, Now we can write the first equation again, that 2x equals to 105. But 2x equals also to 2 times AP. 2x equals to 105 and 2x equals to 2 times AP. So we can add here that 2x equals to 105 and it also equals to 2 times AP. Okay? 2x equals to 105, but 2x equals also to 2AP. And here we have the equation that 2AP equals to 105. So we write it down. Okay, so we arrive to the final answer that 2 times AP equals to 105 units. Okay, I will add the units. Okay, so 2 times AP equals to 105 units. So I will summarize the lecture. So actually we wanted to find the value of 2 times AP, or the size of 2 times AP, and we have already know that the size of AC is 70 units, the size of BC is 50 units, and the size of AP is 90 units. And we also know that side AC is tangent to the circle in point D, and side BC is tangent to the circle in point E. So we connected between points P and C, and we also connected between points P and D, and actually PD is the radius of the circle, because it starts from the radius of the circle and touches the circle. This is actually the definition of radius. So PD equals to the radius of the circle, and for the same reason we connected points P and E, and PE is actually also the radius of the circle. So actually we know that a rule that says that if you from an external point of a circle, if you draw two tangents to the circle, then they must be equal to each other. So FV equals to MV, and for the same reason we can say we have from external point of this circle, point C, we have two tangents to the circle. For that reason they equal to each other. So CD equals to CE, and also PD equals to PE, because they are both the radius of the circle, and PC equals to itself. So we can say that this circle in the green color equals is congruent to this circle also in the green color, because they have three sides, because three sides on triangle PDC equals to three sides in triangle PEC, because this side side DC in this triangle equals to side EC in this triangle, and side PD in this triangle equals to side PE in this triangle, and PC equals to itself. So we have three sides on triangle PDC that equals to three sides on triangle PEC. Therefore, they are congruent, they overlap. Okay, and for that reason, actually, we can deduce that angle PCD in the red color equals to angle PCE in the blue color, according to the rule that corresponding angles in congruent triangles are equal to each other. For that reason, angle PCD in the red color equals to angle PCE in the blue color. So if angle PCD is theta, angle PCE is also theta, because those two angles are equal to each other. And we also have, I drew triangle ABC again, and according to angle bisector theorem, if angle bisector, that is in our example PC, it divides angle ACB to two equal parts. This angle is theta and this angle is also theta. So, and it hits angle AB in point P. So it divides side AB, to two parts, and the ratio between those two parts, that is to say the ratio X or the ratio AP over BP, equals to the ratio of the sides of the angle that this angle bisector divides to two equal parts. So the sides of the angle that it divides are AC and BC. So the ratio between those two sides, that is to say AC over BC, equals to the ratio that angle bisector divides and side AB. Okay, so AP over BP equals to AC over BC. Okay, so, and we defined AP as X, so BP must be 90, that is AB, minus X. And we actually put it in the first equation, and we actually solved one equation with only one variable, that is X, and we got the answer to the question, that is to say 2AP equals to 105 units, or 2 times AP equals to 105 units. Okay, thank you very much.